For part B, our function is now defined as the rational expression x plus 4 divided by 3 minus x. So once again, we have a four-step process. Step number 1, replace the f of x by y. Step number 2, interchange the x's and the y's. So everywhere I see a y, it's going to become an x. Everywhere I see an x, it's going to become a y. Oops, 3 minus y. So now that I have interchanged the x's and the y's, the next step is to solve this for y. Now, in order to solve for y, I need to come in and think about how to undo all the things that are happening here. Well, the first thing I notice is I have a big old fraction. I'd like to get rid of that fraction. So I can multiply both sides by the denominator, 3 minus y, to accomplish that. So on the left-hand side, I would have x times 3 minus y. And on the right-hand side, we have y plus 4 divided by 3 minus y times the 3 minus y. Here, the 3 minus y's cancel. So on the left-hand side, then, this becomes x times the quantity 3 minus y. I can distribute that x. So we're going to have 3x minus xy, and that's going to equal y plus 4. Now, at this point, it's tempting to come in and say, oh, if I subtract 4 from both sides, I'm going to have y alone on that right-hand side. However, you have to be kind of careful about that, because while we would have that y alone on the right-hand side, we would still have a y running around on the left-hand side as well. And if you have a y on both sides of the equation, that means that you haven't finished solving for y. So we need to make sure that if we solve for y, we have y alone on one side, but we also don't have any y's still on the other side. So in order to make that happen, then, we need to do some very special steps in the next few steps. What we need to do is get all the terms that involve y on one side of the equation, and then we need to get all the terms that don't involve y together on the other side of the equation. And that's worth a written comment. So I'm going to say, gather the terms that involve y. So I notice on the left-hand side, I have a negative xy. And on the right-hand side, I have a y. So I'm going to go ahead and choose to have all of my y terms on the right-hand side of this equation. So in order to get the y terms on the right-hand side, this y is already there. So I'm going to go ahead and just leave him on that right-hand side. But this negative xy over here, in order to bring him over to the right, I'm going to have to do an addition. I'm going to add xy to both sides. So if I add xy to both sides, we're going to have plus xy sitting here. Now that I have that, then, the next thing that I can do is come in and think about what's going to happen if I bring all of the terms that don't involve y over to the other side. Well, this 3x is already on the left-hand side, so I'm going to go ahead and leave him over there. And then this 4 on the right-hand side, he doesn't involve an x, so I'm going to move him over to the left as well. So in order to move that 4 over to the left, I need to subtract. So I'm going to subtract 4 from both sides, so we have then 3x minus 4. Now at this point then, we have 3x minus 4 is equal to y plus x times y. Now, what I'm going to do is think about how to move forward in terms of getting that y alone. And again, it's very special steps that I have to do as my next few pieces. So the next thing that I need to do is say, okay, why did I just do all of this stuff about gathering all the y's? The answer is to prepare me for the next step. I want to see then that this problem, if I ignore the left-hand side for a moment, is really a factoring problem. And as a factoring problem, both of those terms involve y. I just made that happen. So I can pull out that factor of y. And again, that's worth a written comment. So factor out the y. So if I factor out the y then, we're going to have y times, well, factor a y out of a y, we're going to be left with a 1. Factor a y out of the positive xy, we're going to have a positive x there. And the left-hand side is still there, 3x minus 4. So now the question is, what did that allow me to do? Well, again, the goal here is to solve for y. So if you look at the right-hand side, notice we have y times a quantity. Multiplication can be undone with a division. So I'm going to divide both sides by 1 plus x. By doing that division, we then have solved for y. So now that we've solved for y, we can go ahead and do step 4. And in step 4, we're going to replace the y by the new and improved functional notation for our new function, f inverse. So step 4, we have f inverse of x is equal to this new function, 3x minus 4 divided by 1 plus x. Now, as we look at this then, we have our function f and we have our function f inverse. At this point, we're ready to think about the domain and the range for both of those. So I'm going to erase some of these steps, and then we'll talk about how to find the domain and range. So, okay, let's start off with the domain of f. One more time, once I know the domain of f, I'm going to get the range of f inverse for free. So let's figure out what the domain of f is. So once again, domain of f means that I need to go back to the original function. F is written as a rational expression. So think about the one x value that would make our denominator 0. If we had an x value of 3, we would end up having then a 0 in the denominator, and we can't divide by 0. So 3 has to be excluded. Now remember, the other thing that you have to think about is square roots. This particular problem doesn't involve square roots, so that wouldn't eliminate any of our x values. So let's figure out how to write down this idea that we want to exclude 3. Now I'm going to choose to write this in interval notation. So I'm coming in and I'm saying, okay, I have a number line here, and 3 is the only number that I don't like. So I'm going to say everything to the left of that's colored in, and everything to the right of that is colored in. So interval notation, start from the left, move to the right. We would have negative infinity to 3. Well, once again, you have to have a parenthesis on that 3 to say that we're not including that 3. But that's not the whole story. We have a whole bunch of x values that we're including here over on the right as well. So I need to keep on going. We're going to have your union symbol, and then we start up again with a parenthesis 3, and then we go over to the right forever. So we're going to have that positive infinity. So the domain of f is going to be then, in interval notation, parenthesis negative infinity comma 3 parenthesis union parenthesis 3 comma infinity parenthesis. And one more time, that's also the range of f inverse. So you might be wondering, why did I choose not to use set builder notation? Well, in set builder notation, we have to write down the variable. So the domain of f would be all about the x's. So I would have to write something about x values down here. But the range of f inverse is all about the y's. So I would have to write something about y down here. So by writing it in interval notation, I don't have to write down my variable, and I can write down one answer that works for both of these. Otherwise, I'd have to put something in terms of x and then also something in terms of y as two separate pieces. So you might be wondering, how would you write that if you chose to do that? Well, you would come in and simply say the domain of f would be the set of all x values such that x is not equal to 3. And then the range of f inverse, you would put the same kind of statement, and you would simply use y's. So can you use the set builder notation? Sure. It just means that you're going to have to use two different answers for this problem. So your choice. My choice would be to go ahead and use the interval notation. Then you have one answer for both. But if you want to break it up into its two separate components, you're certainly welcome to do that as well. So now that we have that answer, remember once again, there's a separate answer. We also have the domain of f inverse and the range of f. So let's go ahead and talk about those. So we have range of f, and that's exactly the same as the domain of f inverse. One more time, it's easy to find the domain, hard to find the range in general. So I'm going to focus my attention on the domain of f inverse. F inverse we have over here, f inverse of x is equal to 3x minus 4 divided by 1 plus x. Once again, there's no square root, but we do have a rational expression, and we do have an x value that would cause us issues. The x value of -1 would make our denominator 0, so we can't use that -1. So, in the same way that we did a moment ago, I can say then that the domain of f inverse is going to be everything except for that -1. And one last time, once I know that this is the domain of f inverse, I'm also getting the range of f for free. So again, I chose to use the interval notation. If you want to use the set builder notation for these as well, certainly feel free to do so. You'll just have to write down two separate answers, one for the domain of f inverse and one for the range of f.